What is the distance from your home to school or work? Give that a little bit of thought. And it's okay if it's just an estimate, that's fine. We're not interested in great accuracy. Okay, do you have an estimate? Okay, now forget the number. We don't really care about that. What I want you to focus on are what units you used in making that estimate. I strongly suspect that you use miles or kilometers. Those are, after all, units of distance. Now, many people will use instead maybe minutes or hours. That is units of time, and that's okay. Sometimes we use travel time to indicate how far something is because that then presupposes that we're traveling with some particular speed, though. But whether used distance units or time units, I strongly suspect that you used either miles or kilometers or minutes or hours. You probably did not use inches or centimeters, or for those of you who might have used time, you probably didn't use seconds. And why is that? Because inches and centimeters and seconds are small units of time compared to the distance or the travel time that we're talking about here. The size of a unit, we want that to be appropriate, comparable to the thing it is we're trying to measure, so that we're not always dealing with humongous numbers. And so just like it is for everyday life, it is in astronomy as well. And but space is really big. Space is really big, and so kilometers and miles are the tiny units in astronomy that are just so small that they're not very practical. And so astronomers use other units to measure distances. The most common of these being the astronomical unit, the light year, and the parsec. Now the parsec we're not going to deal with today, but we will talk about the astronomical unit and the light year. The astronomical unit is the average distance from the Earth to the Sun, center to center, and average because the Earth's orbit around the Sun is not a perfect circle. So if this dot is the Sun and the Earth goes around, the Earth's orbit is not perfectly circular, and it's actually technically an ellipse. So there's a time of the year when the Earth is further from the Sun than it is at another time of the year 6 months later. And now the difference, even this drawing here, they look pretty similar. I've even exaggerated that. It's really only a couple percent difference. It is not responsible for the seasons. It just is not terribly significant. But if we take the average distance is 1 astronomical unit, and it turns out that that is 150 million kilometers is the average distance from the Earth to the Sun as it orbits. And this is a rounded number, of course. It's not exactly, these aren't all exactly zeros, but rounded to the nearest million miles, it's 150 million miles. And so this is the unit that we use for measuring distances within the solar system. And so I have over here just a list of the planets in order of their distance from the Sun. And Earth, by definition, is 1.00 astronomical units from the Sun. Again, that's the average distance. And all of the planets pretty much go around the Sun in their ellipses, but they're pretty darn close to circles. And in the case of Mercury, it's 0.39 astronomical units. Venus, it's 0.72 astronomical units. Mars, 1.52. Jupiter is 5.2. Saturn is 9.5. Uranus is 19.2. and Neptune is 30.0. And these are all in astronomical units, or AU, we'll say, for shorthand. And so these are the average distances of these planets from the sun, measured in astronomical units. And you can just see then that this is just a convenient yardstick. I will often say a yardstick used for measuring distances within the solar system. The real quick before we move on to talk about light years, notice how much bigger Neptune's orbit is from the sun than Earth is, 30 times. So I'm taking this opportunity to point that out. When you see a poster or a diagram or something that has the planets, sun and then the planets lined up, very typically they will be just laid out, almost like they're equally spaced, but that's not accurate. Neptune is 30 times further from the sun than the Earth is. Okay. Remember that question I asked at the beginning of the video about distances? Some of you may have answered in terms of time, and that's very, very common. From here, if I were going to drive to the beach, it would take about 3.5 hours to get there at typical highway speeds. So I might say the beach is 3.5 hours away. Well, astronomers do the same thing, and that's the basis for the light year. The light year, by definition, is the distance that light will travel in 1 year. And it turns out that that is about, well, I'll write it out as a number first, not in scientific notation. That is 1 light year. It is, if I put in my commas here just to keep track of the zeros, that is rounded, of course, rounded. That is the number of kilometers that is equal to 1 light year. We can also write that as 9.5 times 10 to the power of 12 kilometers. Now, where did that come from? Let's go ahead and do the calculation real quick to show where that number comes from. The basic relationship between distance, velocity, and time is this. D is distance, velocity is v, you might also say speed, that's fine, and T is for time. And so, for instance, that example of going to the beach, 3.5 hours away. Well, let's say you're driving at 60 miles per hour. So 60 miles per hour. And let's say you're going 3.5 hours. So 60 times 3.5, that gives us 210. 210. And notice it's miles divided by hours. Miles per hour times hour. The hours cancel because this one's on top, this one's on bottom. So you have hours over hours, and that's just 1. You can ignore that. So 210 miles is how far away the beach is if we say it takes 3.5 hours to get there at typical highway speeds. So let's do the same calculation with light. Distance is velocity times time. Now the speed of light is 300,000 kilometers per second. Again, that's rounded, and we could also write that as 3 times 10 to the 5 kilometers per second. And so we've got 300,000 kilometers per second, and the time is 1 year, because the definition of a light year is the distance light travels in 1 year. But we've got a problem here. We've got kilometers per second as our units, but we're multiplying by years. So I can't use years. I have to plug in for the time, the number of seconds it is in a year. So I'm going to do a little calculation. Let's see here. There's 365 days in a year, and there's 24 hours in a day, and each hour is 60 minutes, and each minute is 60 seconds. So if we multiply all those together, times, that works out to be 3.15 times 10 to the 7 seconds. And so this can also be written as 31.5 million. So I'll go ahead and I'll write it this way up here. So 300,000 kilometers per second times 31.5 million seconds. Let's see here, there we go. So 31,500,000 seconds. And if you reach for your calculator, punch that in, you're going to get 9.5 times 10 to the 12 kilometers, or again, written out 9,500 kilometers. And so that is a light year. And a light year is typically the distance unit that we use for measuring distances between stars. So for instance, the nearest star to our own solar system, not counting the sun, but outside of our solar system, is a little over 4 light years away. So that's what a light year is. That's what an astronomical unit is. And those are the yardsticks that we're going to use in astronomy rather than measuring distances in kilometers or meters or miles. One last point, just a point of trivia. How many astronomical units are equal to a light year? And so we're going to take the distance of a light year, divide by the number of astronomical units, and that'll tell us how many there are in a light year. So a light year, 9,500, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We double check that. Okay. Kilometers, so that's 1 light year, divided by 150 million. Kilometers, that ratio is going to give us a pure number. How many astronomical units fit into 1 light year? And the number you get is 63,000. So 63,000 astronomical units is equal to 1 light year. If I can go back to the initial question that we started this video with, measuring the distance from your home to school or work, typically you're going to use miles or maybe kilometers, not inches. And coincidentally, this number is almost exactly the same as the number of inches there are in 1 mile. Just an interesting little trivia tidbit that an inch is to a mile as an astronomical unit is to a light year.